Good evening, and my name is Hawileh. I'm a professor of civil engineering at the American University of Sharjah. Today's topic is about the effect of URAP anchors on the strength and ductility of externally bonded RC beams with mortar bonded galvanized steel mesh GSM sheets. This is the work of my student, graduate student Douier, and the work has been co-advised by Professor Jamal Abdalla. This is the outline of the presentation. The idea here is to strengthen beams in flexure with the GSM galvanized steel mesh sheets with mortar adhesives. The mortar is a cement-based and it's provided by a company, both the GSM and mortar from a company from Italy. It's called Caracol, and their support is highly appreciated. And here we want to study the effect on enhancing the strength of RC beams. For the unanchored specimen, it failed by debonding of the sheets. In order to prevent that failure mode and to enhance the performance of the beam further, we anchored the ends with URAPs. And another possibility is with the same amount of area that we anchored the ends, we anchored intermediate intervals along the span of the beam. As you know, the conventional method of steel, of concrete retrofitting and repair and strengthening is using steel plates. Over the years, fiber reinforced polymer composite materials, sheets and plates like FRP, they call them FRP. They were used in lieu of the steel plates because they are lighter and their strength to weight ratio is much more than that of the steel, and most importantly, they won't corrode. And recently, they came up in the construction or in the repair market with the galvanized steel meshes. You can see them here. This is a low density, so basically there is a spacing between the fibers or between the cords. You can attach them to concrete, this one with either mortar or epoxy adhesives. This is the high density. Only with you can only apply epoxy to concrete in order to attach it, and this is medium. You can use either mortar or adhesive. And the research significance, as I told you, the literature is lacking information on the behavior of longitudinal mortar bonded GSM laminates, especially if anchored with CFRPU reps. And we need to investigate and compare the failure mode and the strength and ductility of the anchored specimens with the non-anchored ones, and also with a control and strengthened beam specimen. So in total we have 4 beams, 1 control and strengthened, 1 control strengthened with 2 layers, with 2 sheet layers and bonded with mortar but without anchors. The third one is the same as the second one but with end anchors, and the fourth one is with intermediate anchors. Okay, so this is our research objectives program. And now this is the literature. We've seen the literature. There is quite, there is some studies that were conducted on galvanized steel mesh that were bonded, especially with epoxy to concrete surfaces. You can see a couple of them. We also published a paper recently on GSM sheets, to enhance the flexural performance of RC beams. And these are other literature review papers. And you'll find few studies that were like investigated the effect of mortar on GSM. So this program, this is the control specimen. The control specimen, it's 2 meters long by 14 centimeters wide, and the height is 28 centimeters. It is reinforced by 2 number 8 bars on the top and 2 number 12 bars in the in flexure here, and you have stirrups, 8mm stirrups that are spaced every 12 centimeters. This is a cross-section view of the beam, and this is the strengthening here. Here we use 2 layers of GSM sheet bonded with mortar, and they span over only 1.6 meter of the beam. Yeah, this is the front view of the concrete beam, and this is here you can see the reinforcement. And here, this is the the GSM sheets anchored. This is the anchored specimen at the end. The width of the anchor is 200 millimeters, and it is 2 sheets here and 2 sheets from the other side. And this is the intermediate one, the one with the intermediate anchors. You can see that the same area is, of anchors is like just spaced across the beam. This is the area of the AFRP anchors, and we took this equation from the ACI 440 guidelines, equation 13.1. And once we put it at the ends and the same area, then we distribute it equally along the span of the in terms of material properties, the concrete strength at 28 days was designed to be 40 megapascal, and when we tested the average, it was around 40 megapascal. The GSM sheets and adhesive used are from Caracol in Italy. It's composed of galvanized steel cords. Each cord is made of 5 wires, 3 straight and 2 wrapped with a high torque angle. This is the sheet that we use, and we can use this one with epoxy or mortar. In this study we use mortar to attach this sheet to the concrete surface. The tensile strength of this steel without the mortar is 2800 megapascal. The density of the sheet is 3.15 cords per centimeter. And this is the modulus of elasticity is like 190 gigapascal, and the strain at failure is 1.5%, and this is geolite cement mortar is used. Again, it has a tensile strength of 10 megapascal. This is the U-wrap sheets that we use at the ends, and they were bonded. These are carbon, and these are bonded to the concrete surface via epoxy adhesives. The elastic modulus of this one is 73 gigapascal, and the tensile strength is 1240 megapascal. And this product is from Mapei, and its specification or designation is VRAP 700, and it has a tensile strength of 72.4 megapascal. This is the 72 of the epoxy adhesive used. This is the mechanical properties of the GSM sheets versus the CFRP. We can see that the strain at failure for both is around 2%. The elastic modulus, but this one, the 73, is because due to the application of epoxy. This one is without the mortar. Once you apply the mortar, it will drop, but at the same time, the thickness of the laminate will increase. This is the control strengthened beam tested under 2-point loading, 4-point bending. This is you see like the clear, the span of that, the length of that sheet is 1600 millimeter. The span is 1.7 meters, and this one is an anchored specimen. All of them, they were tested under the same loading scenario, a simply supported beam. And now, in terms of results, we are going to now here, before we go to the results, or here, we measured the mid-span deflection using an LVDT, and then we recorded the load versus deflection at all stages of loading till failure. You can see the control specimen here. This is the control. This is the strengthened and anchored specimen, and these are the 2 anchored specimens. The red one is with end anchorage, and the blue one is the intermediate anchors. It's interesting, this is the control specimen. It has some ductility. It's a conventional failure by yielding of the steel reinforcement and concrete crushing. The strengthened specimen, it reached, the load increased from about 85 kilonewtons to about 130 kilonewtons. That's about 50% more. And this, but at the same time, it failed at at a lower that has, the specimen has no ductility. You can see it's a straight line. In addition to that, the beams here, the anchored ones, they have slightly lower failure load than the unanchored ones, but they failed at a larger ductility. You can see they have they exhibit more deflection till failure than the control unanchored specimen. This means that the failure will be ductile, and they failed by yielding of the tension reinforcement and concrete crushing. So basically, to conventional concrete. The unanchored specimen, it failed by debonding of the sheets from the concrete surface. And these are the loads. You can see here that the unanchored has reached the highest load, and then you have the end anchors 128, but they are very close to each other. And this is the intermediate anchors. The deflection, you can see that the beam deflected more than the one with the unanchored and the controlled specimens. This means that anchoring the ends of or intermediate anchors of the sheets to the concrete will enhance the ductility of the specimen. Not only that, you are going to change the failure mode from brittle debonding to to flexural failure by yielding of the steel reinforcement and concrete crushing, and this will provide a ductile strengthened structure, which is favorable over the brittle strengthened structure. You can see here some of the specimen. This is the control specimen. It failed by yielding of the steel reinforcement in conventional flexural failure and concrete crushing. And this one is with the end anchors. Now this one here, let me show you the one without anchors. It failed by debonding. And this one with end anchors, it fails by, you can see it here, flexural failure by yielding the steel and concrete. And this one is with the intermediate anchors. The ones before that I showed you, the one that is not anchored, it failed by debonding of the sheet from the concrete surface. And here you can see yielding of the steel reinforcement and concrete crushing, and you have some local debonding between the sheets, and also for the unanchored specimen. So in conclusion, using GSMC sheets can increase the strength of reinforced concrete beams in flexure up to about 50%. If you don't anchor the ends, the ductility will decrease. This is common. As you increase the strength, the ductility will be increased. However, if you put end anchors, your wraps at the ends, your ductility will increase to up to 270%, which is very good. And also, if you can reach up to 257% over the control and unanchored specimens. Thus, if we anchor a beam strengthened with GSM sheets and a layer of mortar, then basically we are not going to worry about the delamination or the debonding failure modes, and the beam will fail in a ductile mode, which is favorable. And according to our literature, the literature is lacking experiments that anchored the beams with GSM laminates with URAS from its ends and intermediate. So this will add some data to the open literature, and we hope that we are right now doing something with epoxy. We are going to combine both of them, and maybe we can write a very good journal paper that will be submitted to one of those well-reputed journals. And those are our references. Thank you very much, and if you have any questions, I'll be more than glad to answer you. Thank you.